Hello, and welcome to another day and another challenge of Advent of Cyber by Try Hack Me. As you can see, we're on day 14, still on networking, and we're doing dev and secure ops. So, McDev, the head of the dev team, sends an alarming email stating that they're unable to update the best festival company's external web application. So without this update, no one can view the best festivals company's plan. The dev team has been using a CI/CD, continuous integration, continuous delivery server to automatically push out updates to the server, but the CI/CD server has been compromised. Oh my God. Can you help them get their server back? So, the objectives in this challenge, we're going to understand the CI/CD concept, overview the risks associated with CI/CD, and have a basic understanding of CI/CD exploitation vectors. So first, let's start the machine. And I'm going to remove that. So what is CI/CD? So it is two terms that is used of software development in DevOps or developer operations. Continuous integration is the process in which software source code is kept in a central repository. An example is GitHub. All changes are stored in this central repository to avoid with different versions of the same code. Continuous delivery is the following, sometimes integral step of the continuous integration model where code is automatically deployed to the test, pre-production, or production environments. CD is sometimes used as an acronym for continuous deployment. Um, so, CI/CD should be considered as a set of practices that are put in place to enable development teams to make changes, test their code, and deploy the application more reliably. So this is a way, again, to make the process more streamlined and not to have it more haphazard. We should think of CI/CD as a continuous process or loop that includes steps of the software development process. So, the risks associated with CI/CD. So the CI/CD integration approach seems to be an effective way to mitigate risks that may result from manually aggregating changes made to the code, manually testing them, and manually deploying the updated version of the application. However, some risks associated with the CI/CD process should be taken into consideration when dealing with such an integration. So, as a penetration tester, one of our goals would be to uncover weaknesses in the automation process. So, this can vary, but what you should do is you should look at the CI/CD automation software and see if there are configuration errors in the file permissions. So, for instance, DevOps teams typically use the standard software for CI/CD, such as Jenkins, GitLab, Bamboo, AWS Code Pipeline, etc. So, the major risks are access security. So, this is the increasing number of integration points that can make access management difficult. Any component integrated with the process may need partial or full access to another component. In this case, allowing too much access can also open a path for malicious activity. So basically, what this is saying is think of this as opening a portal. So every time you add a component, you add a portal. So as you keep adding components, you're adding new portals. And as you can imagine, if you have so many portals, there's now you can have so many ways to get into the application. Permissions. Components are connected with each other and perform their tasks with user accounts. Similar to access security, user permissions should be checked, right? Because you don't want the permissions to be overly permissive, meaning having too much access. Keys and secrets. Many integrations are done using keys, API keys, application programming interface. That's what API stands for. ID keys or secrets. These should be secured, right? API keys, ID keys, secrets should not be laying around. These should be secured. One way to do this should be in a vault, right? These should be in a vault. Otherwise, anyone could potentially access resources using this authentication method. User security. User accounts are another successful attack vector, often used by cyber criminals. Any user who has access to the source code repository could include a malicious component in the code base and could be included in the deployment application. Default configuration. Some platforms are known to have default credentials and vulnerabilities. If the default credentials are not changed and in use within the CI/CD process, this could result in the complete compromise of the infrastructure. So for instance, let's just say we are using GitLab, right? We're a dev shop, a developer shop, and our CI/CD, and we're using a CI/CD of GitLab, and the default configurations for the username and password is GitLab. This isn't the case. I'm just using this as an example. Now let's just say we're using this for our environment and we don't change the default username and password. Well, if I'm a penetration tester and I do research and I notice, hey, for this version of GitLab, I noticed there's a default configuration of a username and password of GitLab, and I tried that and I gained access to your system. Well, now I have the keys to the kingdom because I have your code base, right? So make sure you are not using default configurations. Make sure you are changing that. So now, how does this play into, remember, the Grinch is, trying to steal Christmas, right? And we have to save it as McSkitty. So the Grinch has put his own version of a CI/CD pipeline in place. He has used bash scripts and scheduled jobs to automate the process. So now we need to dive in. So visiting 10.10.101.235, which is our IP from your browser, will show the Grinch is waiting for the loot, but not here. At this stage, we can run a derb scan to discover the 10.10.101.235 admin page, which looks promising. So derb is a tool which allows us for force browsing, which is to look for unrelated content and to look for files, directories, and things of that nature. So if we look at the source code, we can see something interesting. There is an iframe that refers to the ls.html page. This page seems suspiciously close to the output from running the ls command. Connect to the target machine using in-browser access or via SSH with the credentials below. McSkitty password 1. Navigating to home, the Grinch scripts folder and running the ls command will show that most of the scripts in the folder are not accessible by the McSkitty user. The content of the loot.sh script gives us a clearer understanding of the ls.html file we have located earlier. The code is simple. It runs the ls command, which is list, and prints the output to the ls.html file. The Grinch can browse the page from anywhere within the network to see the loot he has accumulated. Clever, this Grinch. However, there seems to be a problem regarding the permissions of his continuous integration attempt. McSkitty can change the contents of the loot.sh file. Change the code in the file to print the contents of the Etsy shadow file. This will be conclusive proof that this permission misconfiguration not only creates a threat for the CI process, but can also be used to escalate our privileges. If you are interested in learning more about privilege escalation techniques, please visit our Linux privilege escalation room. The misconfiguration can be leveraged to read the contents of the Grinch's other scripts. Let's have a look at the check.sh script using the vulnerability we have used to read the Etsy shadow file. Within a couple of minutes, the 10.10.101.235 admin page will update to reveal the code of the check.sh script. This script checks for the existence of a file named remindme.txt in the loot folder. If it finds the file, it prints the Grinch's password to an HTML file that will appear in the 10.10.101.235 pass.html file. Grinch's memory isn't what it used to be. Alternatively, Miscicd could create a file named remindme.txt in the home the Grinch loot folder and wait for the automation to work its magic. Can you answer question 4 using this vector? So, lessons learned. This CICD simulation aimed to help showcase major vulnerabilities that are often seen in CI/CD automation. A locally installed Jenkins application can have an unpatched component deployed for various operational reasons. However, it is rare that a critical vulnerability remains unpatched for an extended period of time on infrastructure managed by a cloud service provider such as Amazon, Azure, or Google because they are used extensively. This is the main reason you will more often see vulnerabilities being a result of improper access management, lax account privileges, or logic flaws, because those are configurations that user in your organization will have to do. Meaning it's not someone at Amazon, it's someone at your organization not configuring it properly. In the example above, we have seen folders that were too lax. The low privileged Miscicd user could write to the Grinch's loot folder. File permissions were misconfigured. The low privileged Miscicd user could change the contents of the loot.sh script. And proper key protection. In this example, Miscicd password can be seen as a secret key used to connect CI/CD components. If the key can be read from a configuration file, the attacker can reuse this key to their advantage. Installation was not secure. Cron jobs were regularly running tasks without any controls for unauthorized changes. As you may have read in sector news, a similar lack of controls has led to the release of backdoored software. So, how many pages did the DERB scam find with the default word list? So now, let's go DERB HTTP 10.10.101.235. And the common word list is common. So you see user share DERB word list common. So that's the common word list. And I'm going to let that go. And then now, how many scripts did you see in the home, the Grinch scripts folder? So now if we go back, we can SSH. And to do that, I'm going to say SSH Miscicd at 10.10.101.235. Yes. Password. Okay. And when you type your password, you're not going to see anything, so it's very important that you type it. Okay, so that worked. We're waiting. So we found the admin page that was said. So now we're in Miscicd. Now, to navigate to the, we're going to say CD for change directory. We're going to go to home and we're going to go the Grinch. The Grinch. And see these scripts. And how many scripts does he have? He has 4. 1, 2, 3, 4. And the reason why this didn't work because in Linux, this is a special meaning, and it's saying start at the top of the directory, the root. So that didn't work. So removing that works. So there's 4 scripts. Okay. And we're going to wait. We're still waiting for that. What is the next question? What are the 5 characters following SG and Pepper's password hash? So let's see if I can. So cat is to read a file, and I'm going to say Etsy shadow. Okay, so in yeah, so I can't read that because I am Xkitty and I don't have permission. So as you can see here, root can read and write and shadow can read. So if we go back and okay, so navigating to the folder. Okay, we navigating to the home, the Grinch scripts folder, and running the ls command. We see that most of the scripts in the folder are not accessible by the Miscfigurations. So looking at the scripts, so for check, cleanup, and test, as you can see, only root can read, write, execute, and for loot, everyone can read, write, and execute. So if I'm not root, so that's interesting. Okay, so if I say cat root.sh var, okay, so ls home Grinch loot. So if I go up a level, okay, so there's nothing here because they're all 0. And I'm going to go back to I'm going to go to desktop. So we have the flag here. We can't see it yet because we're not root. So let's, okay, this is still running. Now, okay, navigating to the, okay, the content of the loot sh script give us a clear understanding of the ls HTML file we have located earlier. The code is simple and runs the ls command and prints the output to the ls HTML file. And we saw that here. It does the ls, and then it prints it to the ls.html file. Okay, clever. The Grinch. Okay. McSkitty can change the contents of the loot.sh. Okay. Change the code in the file to print the contents of the Etsy shadow file. So now, what we're going to do is, so we're going to, let's see. Okay. Okay. So I changed it. That was very weird. Okay. So because yeah, I have read write execute, which means I can change it. So before it was printing home the Grinch loot. So now what I printed was Etsy shadow. So what's going to happen now is if this worked correctly, it's going to print the contents of Etsy shadow. And let me go to, okay. I don't think that worked. To print the contents of the Etsy shadow file. Okay, so so uh, so now I'm going to say cat vi because I want to show what's inside the Etsy shadow. Okay, I don't think. Okay, and this misconfiguration can, let's have a look at the check.sh script using the vulnerability we have used to read the Etsy shadow file within a couple of minutes. Okay, so I think this is not. No, so it looks like we. Oh, it looks like it's worked. I have something here. So I changed it to cat Etsy shadow, and I have something. We have something. Let's see. We have something from the Grinch. So it says, what are the 5 characters following SG and Pepper's password? Let's see. Oh, was this not it? Oh, Pepper. Whew. Okay. SG. 1, 2, 3, 4, 5. Okay. What are the contents of the flag txt? Um. Okay. What are the content? Okay. So hold on. Let's see if the. Okay. We have how many pages? 4. Did it find? 4. Okay. What is the content of the flag txt file on the Grinch's user's desktop? Okay, so let's go back. Okay, so the script for the existence, okay, this misconfiguration can be, okay, let's have a look at the check.sh script using the vulnerability we have used to read the Etsy shadow file. Within a couple of minutes, the 10.10.101.235 admin page will be updated to reveal the code of the check.sh script. The script checks for the existence of a file named remindme.txt in the loot folder. Okay. Alternatively, Miscicd could create a file named remindme.txt in the home, the Grinch loot folder, and wait for the automation to work its magic. So let's do that. So let's create a. Let's go. And let's touch remind me. What was it called? Remindme.txt. So now we have created a remindme.txt. So the script checks for the existence of a file named remindme.txt in the loot folder. So we're in the loot folder and we have created a remindme.txt. Now, you notice that Root and the Grinch have created folders, and we have created this remindme.txt, but this is misconfigured, so we're hoping that the script is not really going to care about the user, and it's just going to be like, hey, we see this remindme.txt, give us the password. That's what we're hoping. It prints the Grinch's password to a HTML file that will appear at this address. So let's go here and let's hope we see it. Okay. Have not seen it yet. Okay. Is there something I'm missing? Okay. So let's go back to the scripts. Now, the check, we can't view this because it can only be viewed by root. We were lucky with loot because it could be viewed by everyone. Read, write, execute by everyone. This can only be read, wrote. It can only read, write, and execute only by root. So we can't open it. Now, so it's like we can't view the file. So it's like, okay, it says the misconfiguration. So but no, we can do it. So let's go to loot.sh and we can say what was it? What was it? Home, the Grinch scripts. Uh, oh, hold on. Okay, so now what I'm doing is I'm going to print the contents of the check.sh because this is running as root. And now I'm going to go here. Let's see. Okay, let's see. Okay, so that. So let me try. I'm always trying ls, and it doesn't like that. So let me try cat. Okay. Okay. So secret password reminder. Remind me. Okay, so it's so the script. Okay, localhost ls response check.txt. Remind me dot text. So why? Okay, elves are fast. Okay, so and it's right there, right here. Elves are fast. Okay, so we actually have the password. So now we can say to the Grinch, and this is switch user. And now we can say elves are fast. And now we see we have switched from McSkitty to the Grinch. And if I type who am I am now the Grinch. So now if I go to if I say pwd for print working directory, if I cd to go back, and I need to see where am I, and ls, and I say desktop, and ls, and flag.txt. Okay. It's saying permission denied. Mm-hmm. Okay, it looks like only root can do this. So if I say sudo l, elves are fast. So it looks like he can do anything. So sudo l is to see what he can do as the root user. So I'm going to say sudo cat flag.txt. Flag. I can spell. Okay. And this is the flag. and this is a trick, and this is sudo-l for Linux, is part of the sudoers file, and pretty much what this is saying is that the Grinch can pretty much run any command as the root user. So when I originally did the cat for the flag.txt and I got a permission denied, I said, let me see what I can do as the Grinch. And it was like, hey, you can do anything as the Grinch. So then I was like, I need to add sudo in front of the command, and then it worked. So I already read the misconfigurations that you can do. This was pretty interesting. I was a little rusty on my Linux. I really hadn't used it in a while, but this was a fun challenge. I learned I learned some things. I hope you learned some things too, and I can't wait to see you in the next one. Have a good day. Bye.